Welcome back, and we're continuing our discussion on fractals, and next we're going to be talking about fractals within medicine and the medical field.
Hello everybody, my name is Ezra Van Brink, and these are my roommates. Today we're going to talk about fractals in medicine. So fractals, as you're aware, are versatile and useful in almost every way. They are not only a sort of concept in math, but also useful and applicable in almost every situation. So they're geometric shapes that are defined by the characteristic of repeating the same concept, but over and over and over. Usually about twice, but as many times as it needs. And so we're going to talk about some of the applications of fractals in medicine, right?
Okay, so this is my favorite quote that I found. It says that in the bloodstream there is a chaos, but no arterial randomness. Okay, so yeah, this quote explains that. Okay, this quote explains that like on the medicine we use like there's not to like there's like all the diseases are actually connected to fractals, and the organism is connected to the fractals. And then I'm gonna be talking about the heart. Okay, the heartbeat of the healthy human heart has a similar pattern. Yeah, and as you can see in this picture, so this is the heartbeat of like a healthy person. This is the like a heartbeat of the unhealthy person. So in a heartbeat of like a healthy person, it's like the scales stay the same. Even if you look like closer and closer, they just stay the same. But then if you check the heart of the scale of the heartbeat for a diseased person, it's not the same. It just goes up and down, and then that it actually like block off its like patterns. And then so scientists like before they actually like could figure out, like scientists like said that, oh, maybe we can use like a fractal to figure this out. And then they use and then they did this. So they also, it's not only that, so like, oh, is this true? And then so they use the mathematical formula to figure it out. So like they use this formula, and then they said that, oh, okay, so if it stays the same, like it's gotta be like close to 0. And then so they calculate the patterns of like the scale of the healthy person, and it was very close to 0. But then they calculated the scale of the not unhealthy person, and it was not equal to 0. And then so this shows the fractal structure of the heart. Like it has a lot of structures, but they're like similar, but it's a lot of them.
Similar to the heart, there we go. Similar to the heart is the cardiovascular system. The cardiovascular system also has fractals, and our cardiovascular system uses fractals to essentially reach every cell in our body. This allows us to have several different forms of tunnels and blood vessels that can transport blood all over. So similar are lungs. Lungs also use fractals as well. And the reason for this is because if we take a fractal and stretch it out and measure its surface area, if it were just a straight line, our lungs would be almost the size of a tennis field, or a tennis court. And so because of this surface area, it allows for the intake of more oxygen, and thus pumping it through our bloodstream to give all of our cells the oxygen that they need to run.
So we can't start fractals. So just to get an input of how cancer works, it's basically uncontrollable growth of cells which fails to die. So in cells, we have normal cells, it grows, divides, and dies. And with cancer cells, it just fails to die. So therefore, you have just an uncontrollable growth within the cells. So that's usually what causes cancer. Now, what they have found, and studies have found about fractals is that they can measure, and it's much more accurate to see or to know whether a person has cancer than most MRI scans or CT scans. Because, for example, when you have breast cancer, it's a subjective. They base it off clumps, and they look at a texture, and they look at, that's all they just base it off. So most really good doctors also look at the DNA, and they can tell by the DNA within those lumps. But what fractals do is, when they look at the fractals, the DNA for that, they realize that within that cell, there is gaps in between the cells, and that fractal cells, the pattern is, if there's more fractal, is the fractalacity, but there is more gaps in between. So that is one way that they can deter if a person is prone or has breast cancer. And another way for a texture is leuconostomy. And so what they have decided is, when they did a study, it was in Santina University, and there was 21 participants. About 21 of them, when they used that method, it's called the practical geometry method, they realized that most, like 20 out of 21, they were able to predict that they had a form of they're prone to cancer, breast cancer, just by using the fractal geometry. And so what this seems like for in the future is, it seems like with more further research, on fractal geometry, and we are be able to see and spot whether or not and predict about cancers such as tumors and all that, just by looking through and measuring through a fractal geometry.
So finally, we've come to a conclusion. Fractals are fascinating, and by observing them in the human body, we can learn more about how the human body functions, learn more about the diagnosis of certain diseases. We can learn more about, the heart, about the lungs, about cancer, and because of this, looking into fractals is a theoretical science that is almost necessary if we want to start taking leaps and bounds into the future of medicine. Thank you much.